All right, so what we're going to do is we're going to talk about some definitions that we need in order to be successful this week. So first thing I want to talk about is an implication. So who can tell me what an implication is? An implication is a relationship that is only valid if the resulting conditional is a tautology. So we mentioned this. We say an implication is a relationship that's only valid if the resulting conditional is a tautology. So I'm going to have, it means I have to have some implication. What do I mean by the resulting conditional?
You must rewrite it.
I have to rewrite it, exactly. I have to rewrite this. And I'm going to rewrite this implication as a conditional. And then I want to know, is this a tautology? Now, where have I seen this before?
In argument.
Or a test.
It was on the test, wasn't it? It was the last two problems on the test. We had an implication, and the very first thing you did, even before you did the truth table, was you rewrote it as a conditional, and you wrote those three little words, is a tautology. So that's the first definition that I wanted to go over today. The second definition I need to go over is tautology. Does anyone know what a tautology is? Yes.
A statement that all truth values are true.
That is always true. God bless you. Tautology is a statement that is always true. So how do I recognize a tautology when I'm doing a truth table?
It's not true.
If it's all true. So in other words, I see that column and it's all the way down, right? That's what I'm looking for. So we've got this implication. It's a relationship that's only valid. We say that a tautology is a statement that is always true. So the third thing we have is an argument. So what's an argument? It's not a statement.
It's a relationship.
It's not a relationship either. Yes, ma'am.
Is there a reasoning that the conjunction of two or more statements
Is a reasoning that the conjunction of two or more statements called premises imply another statement called the conclusion. So we saw this on the last test. We also saw this on the extra credit project, right? You had to come up with your premises, you had to come up with your conclusion, and you had to prove whether or not the argument was valid or invalid, because it is an implication. So we're going to be using these three definitions for the next week, talking about arguments. And there are certain arguments that show up so often, there are certain arguments that are so prevalent that we give them special names. And so that's what we're going to be talking about today. So the first argument that we're going to talk about is modus ponens. Now, by the way, the arguments that I'm going to give you today, these are not definitions. These are not where you have to have an is-a part and a has-a part. These are a pattern of symbols that we need to know. And by know, I mean memorize. Now, keep in mind that these are arguments, so we're going to have the conjunction of two or more statements called premises, and they're going to be implications because they're going to imply another statement called the conclusion. Modus ponens follows a very particular order. I have to start with a conditional, P conditional Q in this case. And my second premise is going to be the antecedent. And my conclusion is going to be the consequent. So notice that I have a conditional, P conditional Q in this case. And, it's got to be an and because an argument says that the conjunction of two or more statements, called premises. My second premise has to be my antecedent. And my conclusion has to be my consequent. Now, something that we've remarked upon is that the actual letters don't matter. What matters is the pattern. So if I had A conditional M, can you tell me what the antecedent is? A. Can you tell me what the consequent is?
M.
So this and my antecedent implies my consequent. That is a modus ponens argument, even though it doesn't use P and Q. I've got open bracket parentheses, A conditional M, close parentheses. That's my conditional. And, because an argument is the conjunction of two or more statements called premises, my second premise has to be my antecedent. It has to match the first part of the conditional. That's why A is my second premise. My conclusion has to be my consequent. So that's why M is my conclusion. I could even have something a little bit more complex, like negation Y, conditional negation G, and negation Y implies negation G. What's important is that my antecedent is my second premise, and that my consequent is my conclusion. That's what's important in modus ponens. Now, what we're going to do today is I'm going to give you 4 arguments. I give you a name, there are symbols that go with that name. We're going to prove that those arguments are true. How do I prove that an argument is valid?
They have to be all true.
I have to do a truth table, and what am I looking for in a truth table?
Tautology.
I need a tautology. Not just one true, all truths. How many falses is enough to mess up a tautology? One false will mess up a tautology. So, the first one I want to prove is modus ponens. How many different letters do you see here?
2.
2. What are they?
P and Q.
P and Q. So what do I put for column P?
True, true, false, false.
And for column Q?
True, false, true, false.
So I've got P and Q. What do I do next? Parentheses. So I've got parentheses P, conditional Q. A conditional is a statement that is only false. The antecedent is true and the consequent is false. So what do I put in this column? Where?
And the second row.
Second row gets a false. Everywhere else is true, true, true. Now that's my first premise. What's my second premise? Conjunction P, right? That means I'm comparing this third column with this first column using a conjunction. A conjunction is a statement that is only true if two given statements are both true. So if I'm doing parentheses conjunction P, where are they both true? First row. Anywhere else?
No.
Nowhere else. So true, false, false, false. This bracket is my antecedent. What's my consequent?
The Q.
The Q is my consequent. And remember that this is going to be a place where the antecedent is true and the consequent is false. That's where bracket conditional Q is going to be. So where is the fourth column true and the second column false?
Third row.
Third row, I've got a true here. No. Nowhere. So if I don't get to put any falses down, what does that mean?
They're all true.
It's a tautology.
Oh, if they're all true, it's a tautology. So if this is a tautology,
It is valid.
then this is valid. Interesting. By the way, helpful hint. Everything we're going to do today is a valid argument. So I should be seeing that tautology throughout today's lesson. This is our modus ponens argument. Notice that I start with a conditional, and my second premise has to be the antecedent. My conclusion has to be the consequent. So any questions on modus ponens? So the second argument I want to talk about is modus tollens. Now, I've mentioned this before. This is not a spelling class, right? So as long as you don't spell tollens P-O-N-E-N-S, I think we're going to be okay. Second, what do you call that little thing at the end of your foot?
The toe?
A toe. And what do you call the clear part of glasses?
Lens.
A lens. So toe lens. Okay? Even though it's spelled weird, it's toe lens. If you think about your toe wearing glasses, doing. Now, modus tollens is another argument. It's going to start off the same way. It's going to start off with P conditional Q. It's my second premise that's different. My second premise has to be the negation of my consequent. So in this case, it's going to be negation Q. And this conjunction of two statements is going to imply my conclusion. My conclusion is going to be the negation of my antecedent. So notice that these are negations. Notice that these are negations. It's important to know that my second premise is going to be the negation of my consequent. So again, if I was going to write this in different symbols, B conditional negation R, what's my consequent?
Negation R.
Negation R. What's the negation of negation R?
R.
That would just be plain old R. So my second premise is going to be the opposite, the negation of my consequent. And my conclusion is going to be the negation of my antecedent. So what's the negation of B?
Negation.
Negation B. The actual letters don't matter. What matters is the pattern. Conditional, antecedent, consequent, that's modus ponens. Conditional, negation of the consequent, negation of the antecedent, that's modus tollens. And as I said, we're going to be proving these arguments today. So what's the first thing that I'm supposed to do? Even before I do a truth table, what's the first thing I'm supposed to do with this? I need to write it again, but write it how?
Conditional.
With a conditional. So P conditional Q and negation Q, conditional negation P is a tautology. So that's the first thing that I have to do. I have to rewrite this as a conditional. Because I can do a truth table for a conditional. A conditional is a statement that is only false if the antecedent is true and the consequent is false. How many different letters do you see up here?
2.
2. What are they?
P and Q.
P and Q. So what do I put for P?
True, true, false, false.
True, true, false, false. What do I put for Q?
True, false, true, false.
feel like we do these same two things over and over and over again, don't I?
True, false, true.
So now that I've got my statements, now that I've got my negations out of the way, now what do we do? Parentheses. So I've got parentheses, P conditional Q, and a conditional is a statement that is only false if...
Given statements are both false.
What? That's the disjunction.
If the antecedent
Antecedent is true and the...
is false.
So which row does that happen on?
Second row.
Second row. That's where my antecedent is true and my consequent is false. That's the only place I get to put a false, which means what?
That the
Everywhere
rest of
else
them
is
are true.
Everything else has to be true. And I'm going to be putting this statement together with negation Q using a conjunction. A conjunction is a statement that is only true if
both given
two
statements
given
are
statements
both
are
true.
So where are columns 4 and 5 both true?
First row.
Nope.
Last.
Last row. That's where they're both true. Remember, I'm looking for parentheses and negation Q. So I'm looking at column 5 and column 4. The only place that they're both true is in that last row. Everywhere else? False, false, false. Now this bracket that we just did, this column 6, this is my antecedent. What's my consequent? Negation P, which is which column? The third column. So I'm looking for trues here and falses here. Where does that happen? Nowhere. So bracket conditional negation P, it's never false. So it's always true. So this is a tautology.
And is valid.
And this is valid. It's important to note the distinction between these. Modus ponens, the first one we did, didn't have any negations, did it? We had antecedent, consequent, antecedent, consequent. Modus tollens had negations in it. I had antecedent, consequent, negation of the consequent, negation of the antecedent. So the order is important when we're doing these. Any questions on modus ponens or modus tollens? All right, so the third one I want to talk about today, hypothetical syllogism. Hypothetical syllogism. Say it with me. Hypothetical syllogism. Now, this isn't a spelling. Hypothetical syllogism looks like this. I'm going to have bracket parentheses, P conditional Q, and because these are all arguments, an argument is a reasoning that the conjunction of two or more statements called premises. I have to have a conjunction. The second premise is another parentheses, Q conditional R. And this is going to imply a third parentheses, P conditional R. Now, yes?
Wasn't that one of the arguments that some of us have gotten on the extra credit?
Mm-hmm. Yes. I gave a lot of these arguments on the extra credit, but there are also some invalid ones that I gave on the extra credit. We're going to talk about that at the end of today's lesson. So yeah, there are three different letters here, right? P, Q, and R, which means if we do a truth table, I'm going to have 2 times 2 times 2,
Which is 8.
8 rows in my truth table. We're going to talk about that in just a moment. Before we do, though, I want to talk about how we recognize this. P leads to Q, Q leads to R. Therefore, P leads to R. So it's kind of like I've got a train. Here's my engine, and here's the car, and this car matches this car, and then I've got a caboose. But if I'm dealing with a train starts at the engine, and a train ends at the caboose, and that's really the important stuff. So I want to go from the engine to the caboose. The idea is that I want these letters in the middle to match. And so all I'm left with is my first antecedent. as the antecedent of my conclusion. And the second consequent to be the consequent of my conclusion. And as I mentioned, we're going to do a truth table of this, but as I mentioned, we have three letters. P, Q, and R. Oh, wait a minute. Before I even start this, what do I have to do first? I have to rewrite this. So I've got to do bracket, parentheses, P conditional Q, and Q conditional R, close bracket, conditional P conditional R, and those three little words we got to write is a tautology. All right. 2 times 2 times 2 is?
8.
8. What's half of 8?
4.
4. Remember, a statement's true half the time and false half the time. So I've got to do 4 trues and 4 falses. Now, what's half of 4? 2. So I've got to have 2 trues and 2 falses, and I need to continue the pattern. So 2 trues and 2 falses. And then half of 2 is 1. So I've got to have 1 true and 1 false. And I've got to continue the pattern. So true, false, true, false, true, false. So now I'm ready to do the truth table for this, which means I'm ready to do what? What do I do first? Parentheses. But which parentheses? Yeah, let's do the first one. P conditional Q. A conditional is a statement that is only false if the antecedent is true and the consequent is false. Which row does that happen on?
Third and fourth.
Third and fourth row. Look, I'm looking at P and Q for true and false. So those are the only places I get to put false. Everywhere else has got to be true. Now that's my first parentheses. Tell me about my second parentheses. God bless you. Q conditional R. God bless you. Q conditional R. So now I'm looking at Q and at R. Where is that true, false for Q and R? Second row? Sixth row, right? So I'm going to have true, false, true, 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 false, true, true. And I'm supposed to do what with these 2 parentheses?
You're supposed to
I need to conjunct them, right? Because an argument is a reasoning that the conjunction of 2 or more statements called premises. The conjunction comes from the definition of argument. And a conjunction is a statement that is only true if 2 given statements are both true. So where are these columns 4 and 5? Where are they both true? First and the last. Anywhere else? The fifth. And the second to the last, so the 7th. So in other words, the second row, no. The third row, no. The fourth row, no. And the 6th row, no. Because there's at least 1 false that messes up somewhere along the way. But the first row and the 5th row and the 7th row and the 8th row, those are true. And this is my antecedent. What's my consequent?
First you gotta do the P conditional R.
Yeah, I got to do P conditional R. So tell me about P conditional R.
The conditional is only false if the antecedent is true and the consequent is false.
That's correct. So tell me what to write. Remember, I'm looking at P and I'm looking at R.
The first
False in
one,
the second row.
False in the second row.
fourth row,
Third, fourth row.
Fourth row.
That's it.
and the last row.
No.
Well, I don't have true, false.
Oh.
So no, not in the last row. That one's going to be good. All of them are going to be good except for the second row
And the third.
and the fourth
I
row.
mean,
Right? Second and fourth?
yeah.
This is my consequent. Do I ever have trues in this 6th column and falses in the 7th column? Do I ever have a true followed by a false? Never. So that means that my argument is true, 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 true. What's special about that?
That is a tautology.
That is a tautology.
And is valid.
And this is valid. By the way, I mentioned everything today was going to be a tautology, right?
Yes.
All right, so we had modus ponens, we had modus tollens, and we had hypothetical syllogism. Those are the three big ones. We have one more argument that we're going to be talking about today, and this is called Theorem 8a. It's called Theorem 8a because in our book, on page 23, it's the 8th theorem on the page. It doesn't have a fancy Latin name like modus ponens or modus tollens or hypothetical syllogism. It's just Theorem 8a. It's also the simplest one that we're going to be dealing with. Theorem 8a states simply that P conjunction Q implies P. Mr. Potter's shirt is blue, and 2 plus 2 equals 4. Therefore, Mr. Potter's shirt is blue. The room is bright, and Uranus is the 7th planet in the solar system. Therefore, the room is bright. It is sunny outside, and the Earth will be destroyed by a massive asteroid. Therefore, it is sunny outside. Have any of y'all ever had a math problem that had extra information? And it was okay to ignore the extra information? This is our extra information theorem. Actually, what we're saying is that if something is true and something else is true, the first thing is true. In other words, we can ignore extra information. But I can't just say ignore extra information. I need to prove that we can safely ignore extra information, that it's not going to cause situations later on. So I want to do a truth table for this, but before I can even do a truth table, what's the first step in proving an implication? I have to rewrite it as a conditional. So I'm going to rewrite this as P conjunction Q, conditional P is a tautology. So P and Q, right? How many letters?
2.
2. So what's 2 times 2?
4.
4. Half of 4 is? So 2 trues and 2 falses. That pattern still works on 2 by 2s, just like it does on 3 statements. Half of 2 is? So true, false, and we continue the pattern. What do we do next? Parentheses. P conjunction Q. What do we put for this column?
True, false, false.
True, false, false, false. Only true when the first 2 statements are both true. This is my antecedent. What's my consequent? P. God bless you. So do I have any trues in the 3rd column? Bless you. And falses in the 1st?
Yes.
Where?
Second row.
2nd row. I've got a true in the 3rd column and a false in the 1st.
They're all true.
They're all true. So conditional P is going to be all true. I did mention they were all going to be true, right? So this is a...
Is a tautology is valid.
And this is valid. All right, so we have 4 arguments. And by the way, all of these arguments can be found on page 23 of your textbook. If you were a post-it note type person, that is a page I would put a post-it note on to find quickly, along with page 11, which we've already said was kind of important. So what I want to do now is I want to talk a little bit about tomorrow's quiz. Because we didn't have a quiz today, did we?
No.
We said we have a quiz almost every day, right? So on tomorrow's quiz, I'm going to tell you that you're going to have to prove an argument is valid or invalid using a truth table. That's going to be the bottom part of your quiz. For the top part of your quiz, you're going to have to do something like this. So I've got open bracket, open parentheses, P conditional Q, close parentheses, conjunction negation Q implies negation P. What's the name of that argument?
Hyper.
No.
It's not going to be hypothetical syllogism because it's not conditional, conditional, conditional. This is modus what?
Modus tollens.
Components,
Modus tollens. Why is it modus tollens?
because it has negation there.
It has the negation of the consequent and negation of the antecedent. Now, if I was to write this, I've got open bracket, open parentheses, P conditional Q, close parentheses, conjunction negation P, close bracket implies negation Q. What is that? It's nothing. It's not modus ponens because the antecedent isn't the second premise. It's not modus tollens because the opposite of the consequent is not the second premise. And it certainly isn't hypothetical syllogism, and it's not theorem 8a. So this is an invalid argument. And how many of y'all on the extra credit were given an invalid argument to prove? I'd say about half of y'all were, because it was supposed to be about half and half. Some arguments are going to be invalid, and that's okay. Invalid is a good response. What if I gave you P conditional Q and Q implies P?
It's nothing.
That's invalid as well. Because if I want it to be modus ponens, then I need to make sure that I have a conditional and the antecedent is my second premise. And my consequent is my conclusion. That's modus ponens. And I've mentioned that you have permission to be lazy, right? So we also have this one, bracket parentheses, P conditional Q and Q conditional R implies P conditional R. That's hypothetical syllogism. Say it, hypothetical
Hypothetical
syllogism. Yes. Quiz, if I was to give you the stuff in brown, would you be able to write the stuff in green? Okay.
No.
No? Well,
Sorry,
you've
no,
got
sorry.
24 hours to get to that point. What if I was to give you the stuff in green, could you give me the stuff in brown? If I give you the stuff in green, if I gave you modus tollens or
Yes.
modus ponens or hypothetical syllogism, could you write the argument in symbolic form? So the thing is, I do expect you to be able to go both ways. I give you the argument name, you give me the argument in symbols. I give you the argument in symbols, you give me the argument name.
So it's like backwards.
It can be either way. And for the second part of the quiz, you're going to have to prove an argument using the truth tables that we talked about. So any questions?